Next, Ina talk, which will be given by Mark Robertson. So it'll be Ina, young or not.
Okay, hi, good morning, thank you. Yeah, I agree with Catherine. It'd be awesome to get a sample back from Ina. Uh, but my thoughts were to do this within a budget of Eclipse mission and get a definitive answer on the question, young or not. So let's go to the next slide, please. I have to go quickly, which I usually don't do because I wander off in the weeds, but I will just got some great help from Catherine. And I loved her statement that the only thing that people can agree on is some sort of volcanic landform. I'm going to definitely use that in the future, but I will reference you, Catherine. So these two competing hypotheses that we already heard about in the previous slides, are important because the conventional wisdom is that lunar volcanism ceased 1 to 2 billion years ago. The Braden et al. Paper looked at small-scale morphology and crater counts. And it's really the small-scale morphology that was pointed out in the Braden paper that people tend to ignore in subsequent works. But they were incredibly important because in the Braden et al. Work, the authors were very skeptical of the crater counts because it was so young. But it was really the combination of the small-scale morphology and the crater counts that led to the publication and the idea that these features are less than 100 million years old. And it was just got an introduction to the alternative hypothesis of magmatic foams by several, I think there's now been 30 or 40 papers that have come out by that group on the topic. But what my thought was that if we can get very high resolution stereo imaging over key areas that we know where they are right now, but we just don't have the resolution with a NAC. But we want to look at small craters, small being less than 20 meters in diameter, and the edges and the contacts of the two units, the smooth units and the rough floor units. Oh, see, I'm a knucklehead. I tried to change the slide. Change the slide, please. Okay, our overarching science goal is just to differentiate, which one of these hypotheses is right, less than 100 million years old or greater than 3 billion years old. And, this is relevant to many science questions called out in key documents. Next slide, please. Okay, our objectives is to determine the physical properties of the two main units, which would be the smooth materials and the uneven materials, which you see examples of it here, and they're very well documented in the Braden et al. Paper. We wanted to delimit and characterize primary volcanic landforms at the 10 centimeter scale, determine the morphology and topology of impact craters down to diameters of 1 meter, and an enhancement to this would be, it's not required, would be investigate the current environment for signs of geologically recent activity, heat flow, and gas release. Next slide, please. Okay, we would land on that biggest smooth mound on the eastern side that you see right here. There's the coordinates. Next slide, please. Required capabilities is the CLPS lander needs to land with a plus or minus 100 meter accuracy, and it needs to transmit 50 gigabytes of science data to Earth within 10 Earth days. And then our science is carried out on an aerial platform from which we would want to get stereo images with 1 centimeter per pixel scale over representative landforms and statistically significant area sampling, because once we get down
Just
to
know, Mark, you have 1 minute left.
we don't know what we're going to see. So the images, we would also want just monostat or single images with a 30.3 centimeter pixel scale over representative landforms, and then stereo images over a broader area but at lower pixel scale, 3 centimeters per pixel, because we'd want to get about 3% INA, and then 20 centimeter per pixel images over 10% of INA. And then also when we're taking off, we want to get 10 frames per second, less than 10 centimeter per pixel scale movie of the ascents. Next slide, please. Okay, here's our notional ConOps, how we would collect those images with 3 different cameras on board a aerial platform very similar to the Hopper being deployed on the Intuitive Machines 2 mission to the South Pole. Next slide, please. And enhance the capabilities, and that's it. Thank you very much.
Thank you very much, Mark.